There was an extra one in that other row. Okay, this is number 86. And the title is Volume. And volume is the amount of space inside a 3D figure. The amount of space inside a 3D figure. So if you are making this box, why do you care about the volume? Yeah. Because you can tell your customers how much stuff they can put in the box, right? So then to measure that, what you do is, well, there's these little blocks. I'm terrible at drawing 3D, but that's supposed to be a block that's 1 centimeter on this side, 1 centimeter on that side, and 1 centimeter on that side. So it's a cube that's 1 centimeter on every side. Since it's a cube that's 1 centimeter on every side, it's called a cubic centimeter. And then instead of writing out the words cubic centimeter, we often put centimeter with a 3 above it, and that stands for a cubic centimeter. So when you're finding the volume, you're counting the number of those that would fit inside. So we could stack them in here. I could be, my kids have some blocks. We could bring them in, stack them in here, and count how many fit in there, and that's the volume. It's how many of these, how many cubic centimeters fit in there. And then that gives you an idea of how much space there is. Okay, now I'm going to, again, attempt to draw 3D, but I'm terrible. So here's a triangle. And then I'm going to draw a triangle here. And this is the front of the figure. And then this is the back of the figure. So it's 3D. So there's a triangle in the front, and there's a triangle in the back. And we're going to have a letter today, which is capital B, and it's going to stand for the area of the base. So capital B stands for the area of the base. And the bases are the two congruent figures. The bases are the two congruent figures. So in this figure, there's a triangle in the front, and there's a triangle in the back. And those two triangles are congruent to each other. So the triangles are the bases. And that's kind of weird because we usually think of base as being on the bottom. On the bottom of this figure is a rectangle, but that's not the base. Because there's not a rectangle on top of it that's identical to it. The bases are the triangle in the front and the triangle in the back. And then the height is the distance between the bases. So in this case, this line here would be the height, because it's the distance between the triangle in the front and the triangle in the back. All right, so that was just previewing how to find volume, but now we're going to have some formulas for volume. So there's 3 formulas today. The first one is if you have 2 congruent bases, the volume is capital B times H. Then there's other figures that just have one base and a point. And the volume formula for that is 1/3 capital B times H. And then for a sphere, the volume is 4/3 pi r cubed. So title today is Geometry 11.5 and 11.6, Day 1. And the first figure is this. Again, I apologize for my 3D pictures. This is supposed to be a cylinder. So it's got a circle on the bottom and a circle on the top. Okay, so first thing we have to figure out, well, the question says find the volume. So the first thing we have to figure out is which formula to use over there. So it's clearly not a sphere, right? Does it have 2 bases, or does it have 1 base and a point? Yes. It has 2 bases, right? The circle on the bottom and the circle on the top. Those are congruent to each other. Okay, so since it has 2 bases, that means the formula we're going to use is capital B times H. That's going to come second, though. So this is the volume formula we're using because this figure has a circle on the bottom and a circle on the top, 2 congruent bases. All right, before we can use this formula, though, we need to figure out what the capital B is. And capital B stands for the area of the base. So in this problem, what shape is the base? It's a circle, so the capital B is standing for the area of the circle. The area formula for a circle is pi r squared. So in this particular problem, the radius is 3. So the area is going to be pi times 3 squared. And so then that comes out to 9 pi. So this part was just figuring out what the area of the base was. Now we take that answer and transfer it to this volume formula. So the volume is the area of the base, which is 9 pi, multiplied by the height. And the height is 5 here. Because it's the distance between the bases. Circle on top, circle on the bottom, 5 between them. So the answer for the volume is 45 pi. And then what would the label be for that?
Centimeters cubed.
Good, cubic centimeters, because we're figuring out how many little cubes would fit inside this soup can. So how much soup would fit in the can, right? As opposed to yesterday, we were doing surface area, which would be when you put the label on the soup can, how much paper you need to cover the outside. Okay, again, I'm going to try to draw a 3D figure. That's a 2D figure, right? What's that shape? Trapezoid, right? This is 3 inches. This is 5 inches. And this is 6 inches. Okay, then I'm going to draw another one, hopefully identically the same shape. It'd be pretty close, I guess. So this is the front, this is the back, and then it's going like this. The back is supposed to be the same as the front. And then this is 8 inches. Okay, so does this shape have 2 bases or 1 base? 2 bases, right? So we're still going to use the same volume formula, capital B times H. So before we can use that, we need to figure out what the capital B is. Okay, now the tricky thing about this figure is there's a rectangle on the bottom, right? It's 5 by 8. And then there's a rectangle on the top, but it's 3 by 8. So the rectangle on the bottom is a different size than the rectangle on the top. And because of that, those are not the bases. The bases are the 2 congruent figures. So in this case, the bases are the trapezoid in the front and the trapezoid in the back, because those are congruent to each other. All right, so when we find the area of the base, that means we need the area formula for a trapezoid. So that's 1/2 times height times base 1 plus base 2. So on the last problem, the capital B formula was pi r squared, because the base was a circle. But on this problem, the capital B formula is this, because the base is a trapezoid. So depending on what shape the base is, you'll have to use a different formula to find the area of the base. All right, so for the trapezoid, remember the bases of a trapezoid are the 2 parallel sides. So we got 5 and 3 for the parallel sides. Everybody okay with 5 and 3 being the bases of the trapezoid? I'm throwing the word base out a lot. There's the base of the 3D figure, which is the entire trapezoid, right? That's the capital B. But then there are the bases of the trapezoid, which is this line and that line. Okay, and then the height of the trapezoid is 6. So then that'll be 1/2 times 6 times 8. So that comes out to 24. So 24 is the area of the trapezoid. And on this problem, that's the area of the base of the 3D figure. So now I'm ready to go over here and figure out the volume. And the base is 24. Okay, now here's the next little bit tricky part about this problem. This H is the height of the trapezoid. See how that's 6? This H is the height of the 3D figure. And the 3D figure is going from the trapezoid back to the trapezoid. So the height of the 3D figure is 8. So then you take 24 times 8, which is 192. And that would be cubic inches. Okay, don't panic, there are not 26 problems on this worksheet, but there is a problem number 26, because I skipped around a little bit when I was numbering. Sorry about that. So anyway, here's number 26, and I'm going to, again, draw a terrible 3D figure. There's going to be a square on the bottom of it, and then there's going to be triangles on the sides. Remember I drew this yesterday? So there's square on the bottom, and then triangle, 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 triangle. It's a pyramid. You're not going to be able to see that when I draw it, but I'm going to try. That's not terrible. So see the square on the bottom and then the triangles on the sides? This is 18, this is 18. That's in centimeters. Okay, now this figure, does it have two bases or does it have one base and a point? One base and a point, right? So because of that, we're switching volume formulas. The volume formula is 1/3 times capital B times H. But again, before we can figure out this formula, we need to go off to the side and figure out what the capital B is. In this figure, what shape is the base? It's a square, good. So we're just going to find the area of a square. So that's 18 times 18. So don't let this throw you off. In this problem, we used pi r squared for the base. In this problem, we used this mess for the base. In this problem, it was easier. We just did 18 times 18 to find the base, because the shape of the base is changing. Depends on what it looks like. So then 18 times 18, I'm not sure what that is.
324.
Thank you. So on this problem, the area of the base is 324. So then when you do volume, you do 1/3 times 324, and then times the height. I didn't tell you the height yet. So when you have a pyramid, the height should start at the point, and then it's going to go down through the middle of the pyramid and hit the middle of the square, right? And it's going to make a 90-degree angle. So here's the point of it. It's coming down through it to the center. That's the height. And on this problem, that's 12. So then you do 1/3 times 324 times 12, and that comes out to 1,296 cubic centimeters. So you can, on this worksheet, you can skip 2, 24, 32, and 34. And there's also a bunch of numbers that are missing, so obviously don't do those either.